Let's take a moment to overview the technology involved with deconvolution in library search. There are several scenarios that use exactly the same technology, so let me explain the purpose behind each. First, let's discuss the quantitation feature unknowns analysis. The purpose behind unknowns analysis is to end up with a list of tentatively identified compounds that are in addition to your target compounds and estimate their concentration. This uses the technique of deconvolution of scan data and then use the library to search spectrally to come up with that list. Another scenario is perceived compounds. Now, perceived compounds typically has two different purposes. One, to confirm the identity using spectral and potentially retention time match quality. Also, you could end up wanting to create a library from those entries, typically done in qual. The last scenario I'd like to point out is one which is very useful in quant, especially with scan data, and that is called new method from acquired scan data using library search. Again, from a technology point of view, there is a deconvolution of the chromatogram and then a searching of the library to come up with a list of compounds that exist in that sample and then populating that into the quantitation method. The purpose being to automatically generate a quantitation method from scan data and save you time. So there are three different scenarios I'm pointing out that use exactly the same technology centered on the library. Let me illustrate my point about the same technology by showing you that in the case here, they all end up doing deconvolution and library search, unknowns analysis, perceived, sometimes called find compounds, and new method from acquired scan data using library search. Now, in addition, it's worth mentioning that there are parameters which control deconvolution, there are parameters which control the library search, and there are parameters which control the compound identification. We'll get to those in detail later on, but it is important that as you go through these scenarios, you have a chance to adjust the parameters for the particular kind of data that you have acquired. To wrap up the overview, let me show you visually what the three scenarios look like. So first, I mentioned unknowns analysis. That is basically a standalone program which is going to take a batch, a quantitation batch, which you identify, a library, which again you get to choose. Here it's the NIST library. And you can generate a report, an Excel-based report. Notice that in each of these scenarios there is a mechanism to get to the parameters that I mentioned, deconvolution, library search, and compound identification. Next we've got perceived compounds. Here I am in the sample information window in quant. I am going to perceive the compounds, or in qual it's mentioned as find compounds. And again, I have the ability to set the parameters by perceived compound settings, and that will lead me to the parameters of deconvolution, library search, and compound identification. Last, I'll point out the new method from acquired scan data with library search. That is when you are creating a new method. You are shown the choice of the library and which sample you want to use. And again, I'll point out that you have a chance to go to the parameters, deconvolution, library search, and compound identification, to adjust that to the kind of data that you're acquiring. So that gives you a flavor for the integrated use of deconvolution and library search in MassHunter, Quant, and of course Qual.